just like that, we are on to one of my favorite topics. Oh yes. Oh yes, we are on to sequences and series. Sequences and series in a nutshell is mathematics as a whole, because in sequences and series, you're all about looking for patterns. And in mathematics there is so much looking for patterns. If you're not looking for patterns, you're not looking for the right things in mathematics. So we take a sequence, I don't know, we take a sequence like 5, 8, 11, 14, and we try to guess what comes next. Or we take a sequence like, I don't know, 3 and 6 and 11 and 18 and, oh, I'll go one more just for fun, 27, and we try to guess what comes next. Or we take a sequence like 2 and 6 and 18 and 54, and we try to guess what comes next. Well, the sequence in the middle is the most interesting of the three, because if I look at the sequence in the middle, I've got, I know how to get from there to there, I add 3. I know how to get from there to there, I add 5. I know how to get from there to there, I add 7. I know how to get from there to there, I add 9. And so it's easy to continue that pattern and figure out what comes next. That's the most interesting, which is why it isn't really part of this screencast. Because the other two are the ones that are not only easy to see a pattern in, but it's easy to extend that pattern to say not only what comes next, but what comes 100th in the list, or what comes 2015th in the list. Here, it's really hard to get at something that gets us the 2015th term. The sequence on the left, plus 3, plus 3, plus 3, sequences like that, where the difference between any two consecutive terms is common, this is called an arithmetic sequence. It's an arithmetic sequence. There is a common difference. A common difference. Plus 3, plus 3, plus 3, plus 3. There's a couple things we can learn from that, and one is how to come up with the nth term of an arithmetic sequence. I'm looking for the nth term. Let's say I was looking for the 100th term in the arithmetic sequence. If I'm looking for the 100th term, how many jumps of 3 am I gonna have to make to get to the 100th term? That's right, I've got to make 99 jumps to get to the 100th term. In general, if I'm going to get to the nth term, I'm going to make n minus 1 leaps of 3. And I'm going to add that on to what? I'm going to add that on to whoever's first in line. So coming up with the nth term, you could learn the formula. You could learn that a sub n is a sub 1 plus n minus 1 times d. You could do that. Or you could think, if I need the 27th term, I'm going to take that 5 and add 3, add 3, add 3, add 3, add 3. How many times? 26 times to get from the first number in the list to the 27th number in the list. Similarly, this sequence over here, where the pattern is multiply by 3, multiply by 3, multiply by 3. This sequence is called geometric. Geometric sequences have a common ratio. Geometric series also have a common ratio, but this is a sequence. It is a list of numbers. Geometric sequence has a common ratio. We are multiplying by 3 every time. To get from any term to the term following, we multiply by 3. 3 is the common ratio. So again, let's think to ourselves looking for the nth term in a geometric sequence. if I wanted to know the 100th term in that sequence, I would start with 2, and then I would multiply by 3, by 3, by 3, by 3, 99 times. I would multiply by the common ratio. Oh, it's not always 2. I would take the first term and multiply by r over and over and over again, n minus 1 times. There's actually an analogous relationship between those two formulas, and I hope that that's not hard to see. Okay, things you should know how to do. You should know how to find the next 2 terms. The next 2 terms. Maybe for this sequence, you should know what the next 2 terms are. And maybe for this sequence, you should know what the next 2 terms are. Shouldn't be too bad. Likewise, you should know how to find the nth term for this sequence and for this sequence. The nth term. All right, a couple other things to figure out. One of those is how do we add things up? How do we add up the terms of an arithmetic sequence? And how do we add up the terms of a geometric sequence? So let's pretend I want to add up numbers in an arithmetic sequence. 7, 10, 13, 16, 19, 22, and 25, and 28. Let's pretend I want to add up all of those numbers. These are 8 numbers in what we will call an arithmetic series. So I could add them up from left to right. I could add 7 and 10 is 17, and 13 is 30. I mean, I could do that, but I think there's a pattern, and where there's a pattern, there is power, because if I have 100 numbers in my list, it is just as easy to add them up as it is to add these 8. And the pattern comes from the fact that with the common difference, those add up to 35. And those add up to 35. And so do those, and so do those. I got a whole bunch of 35s. The sum of those 8 terms is a bunch of 35s. How many 35s? 1, 2, 3, 4 of them. Where does the 4 come from? Well, there are 8 numbers in the list, and we pair them up. There are 8 numbers in the list, and we pair them up. There are 4 pairs that add to 35, and that's 140. Now that's much easier than adding the numbers from left to right, and it's generalizable. If we were to add let's see, if we were to add 200 plus 196 plus 192 plus and so on until there were 80 terms. How would we do that? Well, we would know that the sum of 80 terms, well, there's going to be 40 pairs, and then I just have to know what the pairs add up to. So I would add up the 200 to whatever the last term in the list is. Oh, wait a minute. We have a way to do that. We know how to find the 80th term of an arithmetic sequence. The 80th term of an arithmetic sequence is 200 plus 79 jumps of -4. To get to the 80th term, I need 79 jumps, and each of those jumps is -4. So, oh my goodness sakes, 79 fours, that's, oh, carry a 3, -316, and that's a total of -116. So this is -116. So what's that? That's 40 times 84, and that is some obscenely, that's 3,360. We were able to add up 80 terms without finding 80 terms. You will find in general The sum of n terms for an arithmetic series is n over 2 times the first plus the last. And that makes a whole lot of sense because this is the number of pairs and this is what each pair adds up to. This is worth having somewhere. That's not too bad. But we can also add up a whole bunch of geometric series terms. We can add up a whole bunch of terms in a geometric series. So I've got n terms in a geometric series. There's a first one, and then that first one gets multiplied by r, and then that one gets multiplied by r again, and so on. The last one gets multiplied by r n minus 1 times. Well, if I'm looking to add these up, the pattern here is more difficult to see, but we use a time-honored technique. We multiply through by r. And the reason we multiply through by r is if I multiply each of these terms by r, I basically get another term in the list. Some term becomes this one, and then there's this guy at the end. This one becomes that one when you multiply by r. And then we do another one of those time-honored things. We subtract. And when we subtract, all of these puppies drop out. So I have, how many s sub n's do I have? I have 1 minus r s sub n's. And on this side, I have g1 pulled out of 1 minus r to the n. So for a geometric series, the sum of n terms is the first term times 1 minus r to the n over 1 minus r. Or, if you like, you can switch those around as long as you switch both of them around. This is nice and worth having. So, for example, if I'm trying to add, I don't know, 3 plus 6 plus 12 plus 24 plus 48 plus 96. Did I get that right? I did. Times 2 times 2 times 2 times 2 times 2 plus 192. I could add them up from left to right, but that's not helpful if there's a lot of them. That's just not helpful. So what I'm going to do is I'm going to say I'm looking for the sum of 7 terms in a geometric sequence. And that's first term times, in this case, I'll say r to the n minus 1 over r minus 1. So I've got to identify the first term. That's 3. What's r? The common ratio is 2. 2 to the 7th, 2, 4, 8, 16, 32, 64, 128. That's 3 times 128 minus 1 over 2 minus 1. 127 times 3 is, I think, 381. And so I can add all those up without having to add all those up. Some things that you should know how to do based on this. For each of the following, I want you to find the 15th term and the sum of the first 15 terms. The 15th term and the sum of the first 15 terms. For 1, 6, 11, 16, and so on. And for 84, oh, not true. For 80, 40, 20, 10, and so on. 15th term and some of the first 15 terms. You should know how to do that based on what you've seen. Arithmetic and geometric progressions are in the landscape of high school mathematics, and so this is a good primer to get you through the rest of the way. Thanks for watching. Practice on your own. See you soon.